So how is it so far? Because there's technical stuff. Oh, it works. No worries. How was it so far? I hope you enjoyed Bar's talk. And by the way, we didn't say this, but this is Orki, and he was here the entire talk. And just for you to know, whoever wins the CTF and finishes him first will be able to sleep with this tonight in his bed. And trust me, I tried it. It's a pleasure. So what? I would not tell you. You would have to win the CTF. I remember you. So first of all, I would like to say thank you for taking the time and attending this talk and Bar's talk and the other talk and spending your time with us. I really appreciate it. I hope you'll find this talk valuable, insightful, and most important, fun. I would like you to have fun listening to me and watching this presentation. So when bugs find you, and not the other way around, because usually we would like to find bugs as vulnerability researchers. This is a presentation I crafted 2 weeks ago, probably, based on personal experience. It's essentially a collective of real-life experiences, real-life examples of myself finding security issues and vulnerability in cloud services without actively searching for them. And what I will do in this talk is I'll dive into all of these examples and share lessons of how I did it and how I was able to actually attract these bugs to me without forcefully trying to find them, which I believe is the very best way to attract research in general. I subtitled the talk, Becoming a Vulnerability Researcher, not because I think that's achievable within 45 minutes. Maybe it is. Maybe I'm that good, I don't know. But because I sincerely believe that information here will be tremendously helpful to anyone who would like to pursue this path in the present or in the near future. So obviously, we're not interested in these kind of bugs. Although, honestly, I don't believe they can survive your cold weather. Maybe they do. But we are interested in these kind of bugs. And this, and this. These are the examples we're going to cover today. I will explain each and every one of them from start to finish, as well as diving into the details, and as well as sharing all the information that I can about how was it possible for me to find them. But before we get into technicals, a quick introduction. My name is Roi Nisimi. I have more than 10 years of experience as a security researcher, mostly in these areas. I like Red Team the most because I like to hack stuff and really see how organizations fall. Just kidding. I mean, not in real, but I hope you understand what I'm saying. And as you know, I work at Orca Security today, and I have many hats in my current job, which means I do a lot of different things. And I'll elaborate about this throughout the talk, but just remember the cool Halloween hats. And on my spare time, I'm really into sports. I like to play basketball. I like to play football. I like to play tennis. I even like to play golf. I know some people think golf is boring. If you're one of these people, please hop on the stage when the talk is finished, and we'll have a little chat about it. So we're going to talk about technical information. It's going to be a technical talk about technical details, about really diving into security terms. But before we get into that, I would like to talk a little bit about mindset, because it's not the technicals that will make you really good at something. In my opinion, it's the way you use your brain and the level of confidence you can reach that will eventually determine if you'll be really good at something. So I would like to set the tone before we get to the security stuff and talk a little bit about mindset. I guess we all know this picture. To be honest, I had it on my screen, on my lock screen, a few years back. And since we were little, we've been taught that this is how hard work looks like. You have to grind all your way to success, to the beautiful diamonds, and you should never give up. And you should always be focused on the goal and try as best as you can. It doesn't matter if you like what you're doing or not. You just need to work hard because this is how you'll get successful. Now, as we grew older, we understood that we can do stuff more efficiently. And then we also got familiar with the term smart work, which is basically like hard work, but you just use better tools to achieve your goal. And ideally, you finish it or you do it in less time. I do support hard work and I do support smart work, and I think both of them are great, and both of them are needed to create success in your life, whatever you're doing. But today I would like us to forget about hard work and to forget about smart work, and I would like us to think about a different approach to our work, something that looks like this. Now, if you're thinking to yourself, it is just hard work zoomed out and cut into different pieces, you are correct. But the way I like to look at it, and the way I call this work, is fun work. And fun work is special because it is not fueled by grind like hard work. It is not fueled by efficiency like smart work. It is fueled by an idea. It is fueled by curiosity. It is fueled by the love of the craft. And this is the kind of work I would like us to focus on today as we dive into the technical details. Your work is going to fill a large part of your life, and the only way to be truly satisfied is to do what you believe is great work, and the only way to do great work is to love what you do. This is from Steve Jobs, and I would not like you to think that we are all naives and you can always love what you do. No, there's always highs and lows, but what I truly believe is that you can always choose to see the things you love the most in the work you do, whatever it may be. And this is the kind of focus I would like us to have in this talk. So hats, plenty of hats. As I said, I do multiple things in my day job. Today I have multiple hats. You can see vulnerability researchers in the middle, but on the sides there are plenty of different things. And to be quite honest, I like most of the hats, but I dislike some of them. Bar, I'm just kidding. I like all the hats. Bar is my team leader, by the way. I like all the hats. It's just for the presentation. But to be honest, Bar knows that some hats I like less, and it's okay. And she also knows that it doesn't really matter to me because no matter what I do, this is how I try to treat it. No matter what I do, no matter what hat I wear in the day, there's always a second hat that I will always wear. There's always an upper hat that I will always wear, which looks like this. And this is the hacker hat. Now, the hacker hat symbols fun, curiosity, asking why, and moving fast. And it's a conscious way that I try to approach the work I do that will allow me to maximize my results, but also my satisfaction and my well-being and my love of the craft. Eventually, I would like to get interested in something that I find fascinating. I would like to develop more curiosity into asking why does it work the way it works. And also I would like to be agile enough and to move fast to find quick answers to my questions before I ran out of curiosity or before the company demands other things from me that are not the things that I find curious and that I know will satisfy me if I'll chase them. So every time I start my day, I have my to-do list, but I always try to remember this hacker hat in order to maximize my results, and also in order to maximize my fun, because I know if I'll have fun, then I'll do a great work. Now for the real life examples. Each example I'll cover from start to finish, as I said, and I'll first explain briefly what the bug is about, and then I'll also break it down and talk about the details and share everything that led me to find it. So first one is bad build. Bad build is a privilege escalation vulnerability we've been able to find in Google Cloud Build. It is a service that is really similar to GitHub Actions. It automates your builds, tests, and deploy of your application, and it's native in GCP, so it's ideal for Google customers. And we figured that each time this service runs a CI/CD pipeline, it's doing it via a service account, which is really high privileged. Now, a service account in GCP is a non-human identity, very similar to IAM role in AWS. And essentially what is happening here is if someone can run CI/CD pipelines using Cloud Build, eventually he will be able to utilize a very high privileged service account, which will eventually, as we figured, could allow him to create a software supply chain attack. Now, if you think about it, who needs to be able to create CI/CD pipelines? Who needs this permission? Probably every developer in the company. This is why this is so interesting and so severe. So what led to me even trying to think about this vulnerability, and what made me develop the curiosity? It was CDR. Now, CDR is an abbreviation of Cloud Detection and Response. It is an offering we have within the Orca platform, and it's basically a cloud-native CM solution. If you heard about CM from the on-prem life, what we try to do here is to collect logs from the cloud vendors and analyze them in order to find suspicious behavior, so we could create valuable detections. Now, my role was to look at, that was not the time, my role was to look at GCP audit logs and to try to see what events look interesting enough to build valuable detections upon them. And one event that immediately popped to me was set YAM policy. Now, YAM policy in GCP is a configuration file that describes who can do what. It has all the human and non-human identities in the project and all of their associated roles. To demonstrate it, I've set up a GCP account, a GCP project for this presentation. So you could see this is the name of the project. Okay, and if we'll do gcloud projects get YAM policy of the name of the project, and I'll just use YQ for pretty print, we'll be able to see I should have done it before. Gcloud login. That's correct. A bonus for whoever said that. And I need internet, and I don't have internet. Okay, forget about it. We'll have to run this presentation without demos, I guess, but it will be cool anyways. So, set YAM policy is being recorded in the audit logs every time someone adds a member to the YAM policy. Every time someone tries to change the role associated with one of the members. Now, the funny thing is that it is being recorded in the audit logs, not with the diff. Because imagine you have a bunch list of members and roles that I've tried to show you. Let's say I add a new member. So the command that will be executed is set YAM policy because I edited the YAM policy. So I would expect the event to have only the new addition, right? But in reality, it has all the YAM policy configuration all at once, which doesn't make a lot of sense, because why would you do that? I mean, you can just record the diff. You do not need to record the whole permissions tree, which is sensitive information. And if an attacker would be able to see this information, it will tremendously help them in their lateral movement efforts. Now, you know what happened when I saw this? You know who jumped in? This guy. So immediately I asked myself, who can read the logs? And if you go to the permissions reference of GCP, you'll be able to see what roles has what permissions. And one of the most interesting roles was the cloud-build.builds.builder, which is unsurprisingly the role that is associated with the Google Cloud Build service account. Now, I thought to myself that if I can create builds and I could utilize this role, I could read the logs, right? And if I could read the logs, I could see the entire permissions tree. So I asked myself, okay, how can I read the logs with the cloud build? And it looks like this. This is a manifest of how to utilize cloud build in order to create a CI/CD build inside cloud build. A lot of builds in a sentence. But I tried to create a Malford version of it, which looks like this. So cloud build is built out of steps. Each step is an execution flow that will be executed in an isolated container. So I decided to choose gcloud as my container and decided to read the logs. And it worked. And I cannot show you this without a demo, but the only permission I need to run this is cloud-build.builds.create. And as I said, probably, very probably, every developer in the organization would have this permission. So it's really interesting to see, and we've been able to demonstrate it, and we've been able to do it ourselves. And we also shared it with GCP, and I'll show what happened right now. So this is the table of what else this cloud-build.builds.builder can do. All the permissions it has. Now, as you can see, logging.private log entries.list is striked through because GCP decided to remove it from the defaults after we've shared our research papers. Now, you can see a lot of artifact registry permissions over here, and you can now understand why this was corresponded to software supply chain risk, because artifact registry is the container registry solution in GCP. So if I have all these permissions on artifact registry, I can do something that looks like this. So this is the main attack path we shared and exampled for GCP themselves, and I'll run through it real quick. And I'll also present what should have been the demo, because I think configuring the Wi-Fi will take too much time. So if an attacker will be able to compromise a developer account, you would be able to create a cloud build. Now, once I can create a cloud build pipeline, I can impersonate the cloud build service account permissions, and then I can list artifact repositories, which are basically containers repositories. And then if I choose one repository, I can list its Docker images. I can then exfiltrate an image, inject malware into it, push it back, and then this image will be deployed in any environment that it should be deployed on. And then I'll achieve my software supply chain attack, and then I could exploit the application for the means that I would like to do. Now, to demonstrate how it should work, to run CI/CD pipelines with Cloud Build, you would have to create a YAML file, ideally named Cloud Build, that looks like this. So as you can see, many things here are commented out because I wanted to execute them one after the other. But these are the steps that one should have take in order to achieve the exfiltration of the image. So I would list all the artifact repositories, then I will find one repository called Orca Pipe, which I'll list all the Docker images inside it and all the Docker image tags to find the latest tag. And this is the most cool part. This is how I will exfiltrate the image. I will pull it, I will save it as a tarball, and then I will exfiltrate it to my own attacker machine. Once it's in my own attacker machine, I can ideally do whatever I want to do. And there are many ways to inject code into container images, which I'll leave for your imagination. But these are the steps we took, and this is how it would look like. In the end of the presentation, there's a QR code for the full blog post, as well as demos, so you can check that out. Second one is sysall. This is a very interesting initial access vulnerability we found in Google Kubernetes Engine. We basically figured that the system authenticated group, which usually is very straightforward, very deterministic, and quite boring, which contains all the principles that can successfully authenticate to a Kubernetes cluster, becomes a nightmare in GCP and in GKE particularly, because as we figured, in GKE, every Google account in the world, doesn't matter if it's from the GCP project where the cluster is hosted, every Google account can successfully authenticate to any GKE cluster in the world, which makes any Google account part of the system authenticated group. Now we'll see why this is interesting in a bit, but keep that in mind. The system authenticated is used within the RBAC configuration of the cluster, which means you can associate permissions to this group. Now, if this group is considered deterministic, but it doesn't, then you'll face a lot of issues. So before we jump into breaking down the vulnerability, let's create a common ground on how authentication authorization works in GKE. So when you send a request to the API server, the request has to go through two components. The first one is the authenticator, who makes sure that the request can be authenticated or not. And then the authorizer, who decides what roles should the requester be getting inside the cluster itself. Now you can see there is an anonymous auth equals to true, which means that even principals that cannot successfully authenticate to the cluster can still go to the authorizer component, but they will get very minimal permissions, specifically this role. Now, by the way, this anonymous auth configuration is a default in all the cloud vendors. This is how they operate. And if you see below, there's my user, Nisimi, which can successfully authenticate to the cluster, and then he will get all these roles. Now, when an anonymous principal, anonymous user, requests the API server, the authenticator will label them with the system anonymous user, which is part of the system unauthenticated group. When I'll be connecting to the API server, I'll be labeled as Nisimi and as someone who is part of the system authenticated group. So you can see the anonymous user role is this one, which is very minimal, and my roles are an aggregation of the roles that was assigned to me specifically, but also roles that are assigned to the system authenticated group. So eventually I'll have some sort of a mesh permissions. Now, what was the trigger for my research? It was, and why do I tell you this? Because I want you to see what led me to even treat and approach this research. We tried to create a honeypot platform, a Kubernetes-based honeypot. We wanted to lure attackers in our clusters in order to analyze their behavior and actions, and then post whatever they're doing. Now, a lot of security vendors already implemented this kind of honeypot, and all of them, without exceptions, utilize the system anonymous and system unauthenticated concept in order to do it, which means they have onboarded the cluster, and then they gave elevated permissions to the system anonymous user or the system unauthenticated group, which eventually led to a situation where anyone in the world could have scanned their cluster and then immediately gain a high level of privileges, which is nice and it works, but it's boring. And we wanted to do something else. I wanted to do something else, which is related to Google Cloud Seamless Authentication. Now, what is it even? I noticed this funny thing, and bear with me on that. Have you ever seen this page, people who use GCP? Yeah, cool. So this is the IAM admin panel. Now, in the IAM admin panel, you can choose principals and add roles to them. You cannot create principals, which means you're only participating in the authorization part. You're not participating in the authentication part because this principal is already created. You're not managing identities in GCP. You're only letting them have the roles you want them to have. Now, if you go to the docs on the right, you can see principals can be many things, but one of them are Google accounts. As you can see also, this is my private Google account. Now, when I saw this, he popped in, and I thought to myself, okay, if I'm not participating in the authentication stage, maybe every Google account can authenticate to any GCP account. It just doesn't have any permissions because no one authorized him to have access. And if that's the case, what if any Google account can successfully authenticate to any GKE cluster, and then he'll be part of system authenticated? And this theory that I just said is true. That's the reality. That's how it works. And then I dived more into the documentation. Here you can see cluster roles, and their you can see system authenticated and authenticated, and the cluster roles, the system cluster roles that are bound to them. This is from Kubernetes documentation. So you can see public info on the bottom is for both authenticated and unauthenticated. And we have discovery and basic user for authenticated. Now, Kubernetes claims, and in a very true way, that all of these roles are not harmful. And it's true, they're not harmful. We can even present this one via demo, I hope. No, I don't have internet, sorry. We cannot present it in a demo. Forget about it. Okay. So trust me on that, they're not harmful. Yeah, we have enough time for this? Build together. Forget about it, that's fine. I know, I'll tell you why I'm not doing this, because then you'll have to visit our website, and then marketing will be happy with me. So they're not harmful, okay? But what if someone will decide to add permissions to system authenticated, which are beyond these roles that are not harmful? What will happen? Bad things will happen. Now, I'll tell you why I even thought that some some Kubernetes administrators in GKE will do it, because the common concept of system authenticated is users that I can trust. If someone can authenticate to my system, I can trust him because I probably gave him a certificate. But that's not the case in GKE, as we've just said, because any Google account can connect. What if I migrate an on-prem cluster to the cloud? Then all this, concept of system authenticated creates a total misconception, and we were right with our theories. over 1,000 clusters vulnerable, tremendously vulnerable to this kind of bug and misconception and misconfiguration. And we did not even scan the entire world. One company is a Fortune 500 company that was vulnerable to this kind of issue. We've been able to get secrets. We've been able to log into SaaS softwares like RabbitMQ. We've been able to fetch scripts. Again, this is all from Kubernetes, Kubernetes secrets, Kubernetes data, config maps, etc. We've been able to, who doesn't like Grafana, right? Good old Grafana. Harbor registry and what not. This was really insane for us. We've been having so many conversations with the people from GKE and more secrets. I know this is a Google-powered event, so I try to keep this private, but this is Google's CISO, Phil Venables, and just to emphasize how big this event was, he took part in the email communication of us and the team to make sure this event is being treated really well and in great caution. So thank you, Phil, for being part of the email conversations. Third one is Leaky CLI, who someone in the audience had questioned about, so thank you for that. Leaky CLI is an information disclosure vulnerability we found among all common CSP's command line tools. CSP stands for Cloud Service Provider. And we figured that there are many use cases with these command line tools that print back sensitive information. Now, usually when we use G-Cloud, when we use AWS, when we use AZ, we use them in our terminal. So whether they print back sensitive information or not, who cares? That's us, right? We run the commands. But what happens when you use these commands in CI/CD workflows? Then these commands, or more accurately, their outputs will be sent to the build logs. For instance, if I use a GitHub action that will use a G-Cloud command that eventually prints back sensitive information, this information will be existed in the build logs, and the build logs, if the repository is public, is available to anyone for watch. Now, why did I even think about looking for this vulnerability in the first place? And this is the most interesting part, in my opinion. Shift left. Shift left is an offering we have in Orca. It's one of our main offerings. It's a really interesting and cool offering. Shift left is a security concept that focus on the, that take the focus from the right to the left. Now, on the right, you have an already deployed application in production. And on the left, you have the development process, you have the build process, and you have also the hosting process. So as Bar said in her talk, and as we figured and the entire industry knows, if you have exposed tokens on public GitHub repositories, they will be exploited in under 2 minutes. And this is something that the shift left solution and people in the shift left industry have been mostly focused on for, I think, 2 years, making sure people are not sharing secrets within their public repositories. Now, when I saw this, and when I really bared with this information that attackers are so invested in public repositories, I thought to myself, if they're so invested in this, why they're not invested in the build logs? I mean, the build logs, and this is just an example, have the potential to leak out sensitive information. So when I connected the dots, he woke up again, and he told me to do more curious work and fun work. These are examples of commands that leak back information to the screen if you use them in your terminal. They will leak back environment variables that may be sensitive and may be secrets. Now, usually when you run these commands in your terminal, as we said, it's no problem. And the funny thing is that if you use the scribe commands, you expect all the information to be back to the screen. You expect the sensitive information, the environment variables, to get back to the screen. Now, I'll not execute it, but if I'll do if I'll do something like this, then I expect all the information to get back to the screen, right? Because I use the scribe, so that's what I requested. But what about update? What about set? If you, many of your software engineers, when you write your APIs, you can decide when you do an update what to return. Now, usually, people do implement things differently, and you can decide to return yes, updated or not when you updated, or set or not when you set, and you can decide to return everything. And this is what happened in all of the CLI tools. So as you can see, I'm updating only one environment variable, but at the end, I'm seeing two environment variables. One of them is the I Love Tennis is older, and we also been able to see it. So I thought that maybe there is something here. Maybe people are not understanding that they might leak information with the update commands. And also, one of the main things that people do with the build logs, especially if they are cloud customers, is to deploy their application to cloud resources. So our suspect was that people will misunderstood this concept, and they will have sensitive information in their build logs, and our suspects were correct. This is a victim, and he says, I can confirm, I'm just kidding, right? This is someone who we secured his sensitive information. He said, I can confirm I'm seeing the issue you're referring to. We're now urgently rolling relevant secrets plus passwords and restricting external access to address this. Co-founder and CDO of a company about their open source project. He or whoever wrote his CI/CD had no idea of this issue, just completely unaware of it. And we've been able to find more interesting stuff with these kind of search queries on GitHub. We did the same for GCP and Azure. And as you can see, we're looking for the complicated use cases for GitHub Actions workflows, for Circle CI, which is a different CI/CD solution, and Travis CI, which is another CI/CD solution. And we've been able to find cool stuff like this. And we've been able to find cool stuff like this. You can see Open API key, as Bar said in her talk, which is tremendously bad. And more stuff like this and this. And that's it. This is a QR code of our research blog post. It has all the information you've just seen, but in their entire length. There are also videos of me recording my screen, which I've not been able to do in this talk, so I encourage you to do it. It was actually a psychological game, right? That I could not do the demo. So you'll have to watch it over here. So to summarize, mindset triumphs technicals. This is my belief, and I contribute the success you've seen here, not to my technical skills, but more to the way that I approach whatever I do, and the way that I've been able to always think about what will bring me the most joy and also create the most value. So the summary and the things I would like you to take from this talk is focus on fun, follow your curiosity, embrace an unforceful spirit, because whenever we start a research, we know where it starts, we never know where it ends. I have many situations where I started a research to find something, to find X, and down the line I didn't find X, but I found Y, and Y was even better. So you have to let go of trying to do things forcefully and just to let yourself having fun and do great research, because that's how great research is being done. And you have to be agile, because all of us have great ideas, right? All the time. and some of us write them on a piece of paper and then forget about them. So in the context of this, if you have an idea, make sure to act upon it as fast as possible to make it real. Yeah, for one final word from this guy, this is the one to cheer for, not me. And that's it. Thank you.
Thank you. Over
there. Hello, thanks a lot for your speech. I noticed that...
Can you stand?
Yeah, sure.
Yeah.
Apologies. So I noticed that you don't have a QA engineer hat. Does it mean that being a security researcher is far away from being a QA engineer?
I didn't have what hat?
QA engineer, quality
QA?
assurance. Yeah.
I should have put one over there.
Okay.
But what was the question? What was the question?
That's the question, yeah. Because I'm a QA engineer and I work close to some of the security, but yeah.
Got it.
Yeah.
So if I would be doing QA and listening to everything I said right now, I would have a lot of points throughout my work where I would have curiosity being built up, right? Because you test the application and then you see, wow, why does it do it? So instead of just filling the ticket, which is your job, that's what I would do, I would also think a few steps further and ask myself, why? Why does it happen like this? So ideally, every researcher is a good QA, right? Because every good researcher tweaks with the application until he sees something that he likes, that builds up his curiosity and momentum. So if the question was from QA to research, the answer is yes.
Okay, thanks you.
Sure. I remember you.
Thanks. Actually, I'm also a QA, but I want to ask a bit on the softer side. I really like the details. Could you tell us, maybe share your personal way to get into the zone, like how you focus on that and how you put yourself in this curiosity mode? I know it can be like
what mode? Of sharp mode, or like?
Yeah, of hacker mode. Yeah, you said that there was this ticking moment. Yeah, when you
got
like.
it.
Okay,
so I'll be honest. I was a really bad researcher a few years back, and then I met a guy, and this guy told me, because I asked him, and he was a great vulnerability researcher, one of the best I ever know. And I asked him, how do you approach the way you do? And he told me, and he was like a young guy, and he was so shy, and was like, I don't know, man, I'm just curious. Like, this is so subtle, but this is so important. And it was really important for me to hear, because I was not curious enough. I was feeling like, I'm doing my job. I like my job. It's cool. But then when I started to think, what creates for me joy in the cybersecurity sphere, and then I started to see a lot of points where I see something and I like it and I want to learn more about it and I want to research more about it, and it completely changed my mindset. So there's no right answer, but I think that if you really are curious about something, find it, and then from there start your journey and your work. It can be small, it can be big, but this is how you build momentum. You just really try to look for the things that you love, and then it just happens from itself. It's unforceful, right? Sure.
May I?
Yeah.
Thank you for presentation. So my question would be, how do you manage to not get accusations of penetration when you try to investigate infrastructure of one of those vulnerable companies?
Say again, sorry, didn't understand.
So you were pursuing this idea of GKE vulnerable clusters.
Mm-hmm.
One of those Fortune 500 companies had that vulnerability, and you investigated that. So what's the process not to get accusations that you penetrate infrastructure of that company?
Good question. I'll call legal.
So they take care. Okay.
So it's a good question. I think anyone who would try to pursue self-employed route asks this question in terms of penetration testing. I have a lot of friends that, maybe I should not say that, but I have a lot of friends who took a self-employed route, and that's what they did. They hacked organizations, and then when they would email them and told them, we hacked you, so now you can see what we did, and maybe you will pay us for future projects. There is, I think, a certain threshold that you will never cross as a penetration tester. You just want to get to the POC level and then drop it, right? And then the company would not be, they would not say anything wrong, because at the end of the day, your intentions were positive. So we did not get anything bad from these guys in the Fortune 500 except thank you. But Google had a lot of issues with them. So, of course, we have legal that would protect us from this. If you are just a single person, there is risk of them trying to take charge. But usually if you stay in the POC zone, and I know a lot of situations of it happening, you're good. Like, they will be thankful instead of angry, right? Sure.
Guys, we have time just for two, 3 more questions, and the last in colors.
Yeah, hello. Thank you for inspiring talk. So my question was about rabbit holes, how you deal with them, because what you show us is like very great presentation, but we didn't, we can't see what's trouble you have.
The troubles.
Yeah.
The hardships.
And actually, how you understand that actually this is a dent and this is a rabbit hole. Thank you.
You have to love the rabbit holes in order to be successful. It's not even a joke. You have to love the rabbit holes, because the rabbit holes make you great. Without them, everyone would be great, right? So ideally, you want everyone to be great, but you like to be greater. So the rabbit holes are for you. They're not against you. You need them. So if you embrace them and they still spark curiosity, then you can use them as advantage. For instance, just as an example, I'm doing a research right now, which I will not tell you about what. And for a month, I'm not finding any solution, and I still like it. I still enjoy it, even though for a month, nothing, no feedback that I'm a killer security researcher, nothing. But I still like it because I still have my curiosity invested and engaged in the research, and I know that's good for me to have instead of bad.
Great talk.
Final one. Final
one?
question.
All right. Great talk. Thanks a lot.
Sure.
Just a curiosity one. So related to your day-to-day work and your findings during those security breaches research and so on, do you manage later on, like as an Orca company, to incorporate the automation, like
in the product?
In the product. So you like, are most of your findings included in the automation in the product later on, or there are some specific when you just reach the company and they say, "Oh, thank you, great talk"?
No, good question.
Well, yeah.
We had a similar question from a different guy over food. So sysall is being integrated in the product. Bad build is being integrated in the product. Leaky CLI, I'm not sure, but usually the company, which is built out of so many people, 100 people, and the way the product is advances should correlate with the research. If it doesn't correlate, then you are not in the right time to market in terms of the discovery, right? So sometimes we try to focus on products that are now trendy in the world, but also in the product. The product is really investing time in developing them, and then we're researching the same services, so we would have a great offering. We will create a PR about the offering and a research, and then we can create more boost to it. But sometimes researchers are researchers, and researchers are led by fun. If I see something that I'm intrigued by, Bar would not say no to me, because she knows it will eventually create good for everyone. So sometimes yes, sometimes not, and it depends of a lot of things.
Thank you.
Thank you.
Yeah, guys, sorry, we don't have time for questions. Let's decide what we're gonna do. First of all, let's clap to Roi.
Yeah.
Thanks a lot. Let's present our gifts. Leave us 3, because we still have a panel discussion. Yes.
You didn't see it. You didn't see it.
If you don't mind, guys, all of you who ask the questions to Roi, please approach him, and he will gift the bags. What we're gonna do next? Please raise your hands. Who's going to participate in CTF capture? Yes. You also approach the Roi. He will give you an envelope. Roi, please show it.
Yeah.
This kind of envelope. With this envelope, you either can go to a classroom, which is on the first floor. You just stick to Roi, and you can go all together to the classroom. Yeah. And where you can start working on that. For those who want to stay and debate on who's guilty on the leaks, either it's a cloud provider or you, please stay here. And that's pretty much it. We won't make a formal closure of the meetup, but we'll be happy to see you all after the session in the hall.
We just need to make an introduction for the CTF.
Yeah, and now it's going to be introduction on the CTF, and the pizza arrives, so right after, go and grab some food.
Okay, a few words about the CTF. And so to do the CTF, you'll need a jump server. The main reason that you need a jump server is because I have installed a few cool stuff on the jump server. It doesn't have any flags. You don't need to crack it to break it. Don't do that. You can get the jump server by going to this link, okay, and use these credentials. You'll get an IP of the jump server. It's an EC2 machine that you can connect, and it will be live only for the next 12 hours, okay?
Make sure you take an image of the entire thing, because you have the URL as well.
The entire information is at the envelope. And the starting point would be this URL. Notice the HTTP and not HTTPS. This is your entry point, and from there you can start and find flags. If you find a flag, take a screenshot, and if you find all the flags, come and show me the screenshot, and I will give you a prize, a cool prize, okay? So come catch us, get an envelope, and find us at the class on the first floor.
Thank you, everyone.